In this video, you'll learn about the triangle angle sum theorem. The triangle angle sum theorem says that the sum of the measures of the angles of a triangle is 180 degrees. So using this diagram, below it says the measure of angle A plus angle B plus angle C adds up to be 180. Now we're going to prove the triangle angle sum theorem. So when we're proving that theorem, we cannot use it in our proof. So we unfortunately can't just say angle 2 plus angle 4 plus angle 5 equals 180 because triangle angle sum theorem. So we can't do that. We have to prove that it actually works. So remember, in a proof, the very first thing we always do is write out what they gave us. So they say triangle ABC with EC parallel to AB. Reason number 1 is always given. We also know that we can fill this in, whatever they're asking us to prove, at the very bottom statement, but since I don't know how many lines I'm going to have, I'm just going to leave it for the time being. When I look at the diagram, the first thing I notice is that I know that angle 1, 2, and 3 form a straight line, which means that they have to add up to 180 degrees. So the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180 degrees because the angles form a straight line. The next thing I notice, and I'm going to highlight so it's a little easier to see, is I have two parallel lines and a transversal. If you can imagine that those continued on and look a little more like what we're used to seeing, you should be able to notice that angle 1 and angle 4 are actually alternate interior angles. So we know alternate interior angles are congruent, which means that their measures are equal. So the measure of angle 1 equals the measure of angle 4 because those are alternate interior angles. The exact same thing happens in the other direction. So here I've highlighted a different transversal, and you can see that angle 3 and angle 5 are alternate interior angles, which means they're congruent, which means their measures are equal. So the measure of angle 3 equals the measure of angle 5, alternate interior angles. Now if you notice, I have the measure of 1 equals the measure of 4. So I can take 4 and replace it anywhere I see a 1. Same thing with 3 and 5. I can take 5 and replace it anywhere I see a 3. So when I rewrite this, again, I'm going to put angle 4 where I see angle 1. So the measure of angle 4 plus the measure of angle 2 plus the measure of angle 5 equals 180. When we take things and plug them in, that's called substitution. Now if you notice, I'm very close to proving what they asked me to prove. I just have these two things out of order. So I need to switch those. And so the measure of angle 2 plus the measure of angle 4 plus the measure of angle 5 equals 180. And when we're switching some things out over here, they're trading places, we call that the commutative property. And now we have proved that three angles in the triangle really do add up to be 180 degrees. In this example, we're given triangles and we're asked to solve for x, y, and z. So I'm going to start with this triangle because it has the most information filled in for me that I noticed first. I know that angles in a triangle add up to be 180, so if I add 59 and 43, which is 102. I know that the total is going to be 180, so I take 180 minus 102, which is 78. So angle X is 78. There are several ways to solve this problem, but the next thing I would notice is that these two angles right here form a straight line. So they're a linear pair, so we know that they add up to be 180 degrees. So if I do 180 minus 78, I can see that angle Y is 102 degrees. And then lastly, I have this triangle on the right. I have two of the three angles. So if I add the two given together, 102 plus 49, I get 151 degrees. I know the triangle should add up to be 180. So if I subtract 180 minus 151, I get 29 degrees for angle Z. In this next example, if you notice, I have these marks here, which you should recall mean congruent. When we have a triangle with two congruent sides, it's called isosceles. And so they have two congruent sides and they also have two congruent angles. So I know that these angles are also going to be the same. If the top angle of this triangle is 80 degrees, and I wanted to know what the remaining angles would be, I could take 180 minus 80, and I get 100. Now remember, that's split evenly between the last two angles, so divided by 2, each angle would equal 50 degrees. So this angle is 50 degrees, and so is this angle. So when I set up an equation, I'm going to set up 25x plus 75 equals 50. To solve, I subtract 75 from both sides. I have 25x equals negative 25. And when I divide both sides by 25, I get x equals negative 1. Remember, it's okay to have a negative x value, but we can't have a negative angle measurement. This next example says if the measure of angle B equals 3x minus 30, solve for x. Similar to the last problem, I have these tick marks, which signifies that these three sides are the same. Remember, when we have three congruent sides, it's called an equilateral triangle, and not only are the three sides the same, the three angles are also congruent. We know a triangle has 180 degrees total, and if I split that evenly three ways, each angle is 60 degrees. So I know that the measure of angle B equals 60 degrees, so that's how I set up my equation. 3x minus 30 equals 60. I add 30 to both sides. 3x equals 90. I divide both sides by 3. X equals 30. In this example, I'm solving for x and y. I'm going to start with the triangle that has the most information filled in, and so that would be this triangle. Even though it doesn't ask me to solve for this angle here, that's what I'm going to start with because it's the only thing that I can currently solve for. So I'm going to add the two given angles together, and when I add those, I get 90 degrees. I know that triangles add up to be 180 degrees total, so if I subtract 90 from 180, I get 90 degrees. So this angle is a 90-degree angle. Now, even though it doesn't look like a 90-degree angle, remember in geometry we don't always get accurate diagrams, so go off of your math and not what the diagram looks like. The next thing I notice is that these two angles are vertical. So we know that vertical angles are congruent. So if this angle here is 90, so is angle Y. once I fill in angle Y, now if I start focusing on this triangle, I have an angle that's 90 degrees and an angle that's 55 degrees. When I add those together, I get 145 degrees. Again, that triangle on the left has to add up to 180, so 180 minus 145 is 35 degrees. So angle X is 35 degrees.